Hello, everyone. My name is Stephen Blackburn from District Administration, and welcome to our EdTalk here today, which is entitled How High-Quality Science Programs Can Improve Reading and Math Scores. And all of this is brought to you by the generous support of our sponsor with us here today, Carolina Science. Now for some very quick housekeeping items before we get to our short EdTalk today. So at the end of our main presentation, there will be a live Q&A with both of our panelists here. You can submit your questions. You can do that now until the very end via the red Ask Question box. It's the one with the question mark in the chat bubbles, and it's at the bottom of your screen there. You can also safely download some assets that are related to today's presentation, including the main report, which we'll be discussing today. And you can do that via, it's the blue box there with the paperclip near the bottom of your screen as well. Additionally, at the end of the presentation, so after the Q&A, a post-event survey will launch on your screen automatically. So we just ask that you please stay on at the very end so you can take part, but it's also there at the bottom of your screen if you need to jump off early for whatever reason. It's the pink box there with the checklist. And lastly, you'll be pleased to know that all of you who are here today and everyone who registered, you will all receive an email tomorrow from us at DA. In that email, it will include a link to the slides as well as the on-demand video. So look out for that in your inboxes. And now it is my pleasure to introduce both of our speakers. We have Dr. Sarah Glassman, who is manager of K-8 curriculum at the Smithsonian Science Education Center. And also from the Smithsonian Science Center, we have Katie Gainsback, who is Assistant Division Director of Professional Services there. So Sarah, Katie, it's great to have you with us today. You may now begin.
Thank you so much, Stephen. As you just heard, my name is Katie Gainsback. I'm joining you from the Smithsonian Science Education Center along with my colleague, Sarah. And I imagine that many of you have probably heard of the Smithsonian Institution before, but you may be a little less familiar with the SSEC, as we call ourselves. So just to give you a quick orientation, we are an outreach center within the Smithsonian Institution dedicated to serving formal classroom educators by leveraging the research and resources of Smithsonian museums and scientists. Over our nearly 40-year history, we work in collaboration with communities worldwide to transform K-12 education through science.
We know that many of you may be facing the problem of decreased language arts and math skills after the pandemic. So one inclination is to solve this problem by increasing the percent of the elementary school day that's devoted to language arts and math. And this is one solution to the problem, but it creates another problem, which is decreased time for science. Science taught well can be very engaging for students. But what if you can do it all? What if you can have really engaging science activities and increase reading and math skills? What we're going to share with you today is how you can do this by using high-quality science instructional materials paired with high-quality professional learning. Our agenda today includes sharing elements of high-quality instructional materials and high-quality professional learning, so that you can recognize them when you're choosing curriculum materials and professional learning. We'll be sharing the results from a study that used high-quality instructional materials and high-quality professional learning, and we'll be sharing some available high-quality instructional materials, and then we will have time for questions. So what do we mean by high-quality instructional materials and high-quality professional learning? So let's pretend that you're in 3rd grade and your teacher tells you, today we're going to start a new unit about weather and climate. So maybe you really love weather and climate and you get really excited, but some kids may not be excited or curious. On the other hand, what if your teacher shows you this picture and asks you what you think? So put on your 3rd grade hat for a minute and observe what you see in the picture and what you see written here. What's going on here? What does this get you thinking about? What do you notice? So if you want, you can go ahead and add some thoughts in the chat. One feature of high quality instructional materials is that students are sharing their ideas about a phenomenon or a problem. Phenomenon is a very popular word in science instruction right now. It just means any natural event in the universe. But when it comes to engaging students, we don't want just any phenomenon. We want something that's interesting or confusing, like snow in July. And then students are going to have experiences where they're doing the work to figure this out. So, for example, to figure out this phenomenon, maybe students would read about different climates. Maybe they would analyze climate regions around the world. Maybe they would graph data to show past weather data on July 15th for different locations around the world. So you can see how high-quality instructional materials in science are interdisciplinary. We're specifically creating experiences for students to build their reading, writing, and math skills as they're trying to figure out why these boys are playing in the snow in the month of July. In a minute, Katie is going to share what we learned from a study where students used curriculum materials like these. But first, I just want to share some elements of high-quality instructional materials in science. First, student work is driven by an engaging phenomenon and or a problem. There's a coherent set of lessons or tasks that students go through. It targets grade appropriate skills and knowledge. It's inclusive design, and it's externally validated.
All right, thanks, Sarah. So before I get into the study Sarah mentioned, I also wanted to address that HQPL, or high quality professional learning. We find that many states are actually putting their own spins on the definition of HQPL, but they largely all seem to share the elements that have been identified in the work of Linda Darling-Hammond, which I've listed here on the slide. So in her review of 35 studies, she and her colleagues identified these 7 elements, which we're using today to define HQPL, and we incorporate into our own programs. So these characteristics include professional learning that is focused on strategies associated with a specific curriculum's content, like our Smithsonian Science for the Classroom modules you're going to hear more about. We utilize active learning in these trainings by engaging teachers in the same investigations their students will participate in. Teachers are also given opportunities not only to share ideas and collaborate with their peers, but also dedicated time to reflect on their own learning. And our facilitators intentionally model the instructional practices with teachers that we want them to employ in their own classrooms and coach them as they try them out in the training environment. Our HQPL is sustained over time with both introductory and intermediate level experiences. So with that, I'd like to share a bit about this study that we have mentioned now, addressing how HQPL and HQIM can impact student scores. So in 2019, the SSEC was awarded an Education, Innovation, and Research grant from the U.S. Department of Education to help us understand whether our HQIM, Smithsonian Science for the Classroom, and supporting professional learning like what I just described can improve student achievement, particularly of high-need students in science, math, and reading. So to answer that question, our third-party evaluator at the Center for Research and Educational Policy randomly assigned schools in North and South Carolina to either a treatment cohort that received those resources and services, or a comparison cohort that continues to teach science in a business-as-usual way. So for the last 5 years, we've worked in 37 schools across the Carolinas. And I have to say a shout out to our partners in both North and South Carolina. I see a few of them on this call. We've worked with them to identify those schools in rural communities and supply 3rd, 4th, and 5th grade teachers with 2 modules from our Smithsonian Science curriculum and 2 tiers of professional learning on each module. So these modules were drawn from our engineering and physical science strands of Smithsonian Science for the Classroom, which are shown here on the screen with yellow and blue covers. Our professional learning focuses first on the mechanical use of the curriculum itself, walking teachers through lesson by lesson what their students will experience as learners. And then after they've had the opportunity to teach the curriculum in their classrooms, we then reconvene to explore the underlying science concepts more deeply as adult learners so that they can build their confidence in facilitating student understanding. So Sarah's going to dig into an example from this curriculum shortly, but I do think it's worth noting that when we talk about one of these modules, we're talking about all of the materials that are needed to teach an entire storyline of lessons, like what is pictured here on this slide. And in addition to all of those supplies, there are also print materials for the teachers and the students, including readers from the Smithsonian Science stories. And those are used in lessons that have embedded literacy connections. So, what did our evaluators find as a result of these instructional materials paired with our professional learning? I could get a drum roll, I would. Students took the Stanford 10 as third graders and again as fifth graders, and those students in the schools that were receiving Smithsonian Science saw a statistically significant gain in their science achievement. If we translate those scores to a percentile and we assume that the average student in the comparison group was at the 50th percentile, which is represented by the gray bar here, then the average fifth grade student in the treatment group, represented in blue, would be at the 57th percentile. So in other words, their performance improved by 7 percentile points. Now, does this improvement hold true when you disaggregate the student data by subgroup? The short answer is yes. Across both North and South Carolina combined, the effect was similar for females. Those students identified as Black, Indigenous, and people of color. They all showed a 7 percentile point gain over their peers. Economically disadvantaged students had a 6 percentile point gain. And for those students in special education programs with IEPs, you can see the effect was even larger. The average student in the treatment group there scored at the 65th percentile, all of which are very exciting trends, at least for us, for science achievement. But what about math and reading? For these measures, our evaluator collected student data from the respective state assessments, which in North Carolina is the end of grade, or EOG, and in South Carolina is the college and career ready assessment. By standardizing the outcomes across those two tests, the evaluator was able to combine student scores and find an advantage of 4 percentile points in reading and 6 percentile points in math among Smithsonian students compared to those students not receiving high-quality science instructional materials.
Thank you, Katie. And now we're going to go back to talking about a specific example and how that example shows some of that high-quality instructional material criteria that we talked about earlier. And as a reminder, those elements include student work being driven by engaging phenomenon and problem, a coherent sequence of lessons, target grade appropriate skills and knowledge, inclusive design, and externally validated. First, I want to talk about targeting grade appropriate skills and knowledge, because when we develop curriculum materials, we're always working backwards. We're thinking about what we want students to be able to do first, and then we're working backwards to figure out how we can get there. So this is an example set of grade 3 science, math, speaking, and writing standards. And the example that I'm going to share with you is from another set of lessons from that same grade 3 weather and climate unit. And these are the specific standards that are targeted in those lessons. And so when we develop those lessons, we needed to figure out how could students use that science standard, which is a variety of natural hazards result from natural processes. Humans cannot eliminate natural hazards, but can take steps to reduce their impacts. So how can students use that to either explain a phenomenon or solve a problem? And so I'm going to show a video that students start out the section of the unit with that shows the problem that they're going to work on over the next set of lessons. see that video, we want them to go through that coherent set of lessons to try to understand and work on solving the problem that they just saw in the video. So first, students are going to read about different types of hazardous weather. They're going to figure out that the damage that they saw in the video was likely caused by a hurricane, and that a hurricane is likely to occur in that same area again. Then they're going to research the best way to design a roof to protect against windy and rainy weather, both by testing materials and by reading about roof design. They design and build a model roof, and they test that model roof with wind and rain. So part of that testing involves measuring different volumes of water that they put on the roof and that come off the roof, and that meets that math standard of measuring liquid volume. And then after they do their testing, some students in each group share the results of their tests with other groups, while other students in each group are collecting data from other groups about their results. So this builds students' speaking and listening skills. And they're speaking and listening for a purpose because they're trying to figure out what the best roof design is. And then ultimately, each student makes a final written recommendation about the type of roof that would be best to withstand a future hurricane, and they support it with evidence. And this meets third grade writing standards. Another feature to look for in science curriculum materials is that students have an opportunity to share their ideas and previous experiences related to the problem or phenomenon that they're investigating. So this is an example of inclusive design. When students first observe the roof damage, they're given an opportunity to share their own experiences in weather like this. And this values students' past experiences and increases their motivation. Inclusive design also means that specific research-based strategies are included to help English language learning students. The curriculum material includes images of diverse people and examples of diverse people working in STEM fields. Student tasks allow for multiple ways to be successful, and student-facing materials are available in multiple languages. For example, the image on the right is from the Spanish version of the Smithsonian Science Literacy Series. High-quality instructional materials are externally validated, and multiple organizations review curriculum materials to determine whether they're aligned to grade-appropriate content standards, whether they're coherent, and whether they include usability features. EdReports reviews comprehensive curricula for grade bands, such as K2, 3-5, and 6-8, to determine if a set of materials meets the full set of standards at that grade level. Next Gen Science reviews standalone units for alignment to the specific set of standards that a unit claims to cover. Next Gen Science also provides a science task screener and additional review tools that can be used for internal review of curriculum materials. And all of the review tools that EdReports and Next Gen Science use to do their external reviews are publicly available in districts and states. You can use them on their own or adapt them. Now I'll turn it back over to Katie to learn a little bit more about the results of the study.
So earlier I shared how HQIM, like this example from Smithsonian Science that Sarah just led us through, combined with HQPL impacts student scores in science, math, and reading. And it was certainly encouraging, at least to us, to see confirmation that these materials and PD can support students' growth. But in addition to that achievement data, our evaluators also explored the parts of instructional practice that are harder to quantify. So they conducted classroom observations to better understand what science instruction looks like for teachers who attended our professional learning and used our materials over those that didn't. They also held focus groups to hear directly from teachers what they thought of the program. And so in those classroom visits during the 21 to 22 and 22 to 23 school years, trained observers cataloged instructional strategies during a single science lesson in both treatment and comparison classrooms. And in their nearly 200 visits, they observed that students in Smithsonian classrooms frequently or extensively were engaging in the kind of activities we would hope to see during student-centered learning. For example, students were seen organizing data 90% more often than students in classrooms without Smithsonian science. Students engaged in experimentation 80% more often, evaluated evidence 2.5 times more often, and made predictions nearly 75% more frequently than their peers. And while all these skills are undoubtedly useful in science, they're also important for developing critical thinkers and global citizens who can work collaboratively and communicate their ideas to others. The evaluators also held focus groups to hear from teachers directly about their experiences, and a few themes emerged from those conversations, which I've listed here. They observed that students were highly engaged in the curriculum. They felt the students better grasped vocabulary because it was being taught in context, which is also reinforced, of course, by the improvement we saw in reading scores. And teachers were very appreciative of all the resources included to teach the lessons and reported an increase in their own confidence in teaching science, with the added support of our professional learning workshops to instruct them in both the curriculum and the content. So I've thrown a lot of statistics at you today, and so I just want to summarize in saying that through mixed methods of data collection, our evaluators ultimately learned that our instructional materials, combined with our professional learning, had a positive and statistically significant effect on students' science scores and positive effects on math and reading.
Thank you, Katie. It's very, very exciting. We just want to share a few high quality science resources. One that we've been talking about quite a bit, Smithsonian Science for the Classroom. That is what Katie has been talking about in the research study, as well as I shared the example from. And this is a K-5 standard aligned series. Each unit, as Katie said before, has a hands-on kit of hands-on materials, a literacy series that features Smithsonian resources and research, and digital games and simulation. The K2 grade band recently earned an all green rating from EdReports, and the full series was awarded the most comprehensive, culturally relevant teaching from Educators' Pick of STEM Awards. Smithsonian Science for Computational Thinking includes 2 free standards aligned units for 3rd grade and 5th grade. They are both problem driven and provide the opportunity for students to build their computational thinking skills. And so now I think we will turn it over for questions.
Yes, definitely. Thank you very much. So as you just mentioned, we are at the live Q&A portion of our presentation. If you haven't already, you can submit your questions by accessing, it's the Ask Question icon at the bottom of your screen there. I'm just going to highlight it so you can find it. But before I get to the questions, just want to remind everyone, we just ask you to please stay on to the very end so you can take part in the post-event survey, but it is at the bottom of your screen as well if you have to jump out before then. So let's see, yeah, we do have a few questions. It looks like this first one is for you, Sarah. Are the Smithsonian materials designed for or aligned to next generation science standards, or NGSS?
The Smithsonian Science for the Classroom was designed from the ground up to meet the next generation science standards. It was not a previously developed program that then we tried to figure out how it aligned. We started with the next generation science standards as the endpoints, and then we chose phenomena and problems that when students explained them or solved them, they would be meeting the next generation science standards.
Perfect. Let's see. Let's go with this one. This one should be for you, Katie. How do I get a copy of the study results?
Sure. So we have the complete summative report. If you are a real, data nerd, that's already posted and publicly available on our landing page for the Smithsonian Science for North and South Carolina Classrooms project. I think we can definitely drop that link in the chat if it's not already shared with you. If you go to that landing page, you can read more about our project and see the summative report on the right and download that. But if you check back in just a couple of weeks, we'll have an executive summary available, which will kind of distill the results down into less than the 100 plus pages that the summative report is, that I think will be a great tool for sharing this work with others that are interested in how science can be a vehicle to supporting reading and math too.
Perfect. Yeah, and I did also push out the related content box at the bottom of your screen there. So all of the resources are there, and one of them includes the report findings as well. So that's great for everyone. Let's see. How much time would this program take up, during a typical school day?
So it sort of depends on the grade level. Lessons range from 30 to 40 minutes a day, with shorter lessons at the K2 level and longer lessons at the 3 through 5 level. And then depending on how often you teach science and how many of the additional extensions you want to do, a unit might take between 3 to 6 weeks at the kindergarten through 2nd grade level, or 4 to 8 weeks at the 3rd grade through 5th grade level.
Great. And I think that, you just answered this question, but I know that someone in the audience did ask, do you have anything for grade 6 through 8? Well, I think you just mentioned that, but you can just reiterate that if you have anything for 6 through 8.
Yes, for 6 through 8, we have a series called STCMS. That's also available through Carolina, and it's also NGSS aligned, hands-on kit, including literacy and math. Yeah.
Perfect. Let's see, next question. And we have about 3 minutes left. So I'm just going to say, if you are submitting your questions and we don't get to it, it's not a problem. We at DA will be sharing them with our partners at Carolina Science, so they can get back to them at some point. But feel free to continue submitting your questions. Let's see. How much time is recommended for professional learning for implementation and beyond?
It's a great question. And I think it really varies, from school to school, district to district, what your needs are. Going back to sort of our characteristics of HQPL, that last one was ongoing. I think that's really the key piece here. And in our case with this project, we were conducting professional development every summer with teachers, kind of getting to revisit, acquaint them with a new module, come back to it, continue to work through, what their challenges were after implementation before moving on to the next module. So it really varies. The more the better, as much as you can spare. But in our case, for this project, we were able to spend typically 2 days with teachers every summer, anywhere from 10 to 12 hours in total. So it was really sort of a deep and robust dive into the content. And I think that really contributed in part to, the success that was translated to students.
Perfect. And let's go to this next one. Do you have a resource or a framework for administrators to use to implement best practices for successful rollout of HQ instruction, high-quality instruction?
That's a good question.
You can jump in, Katie,
Yeah.
if you want. But I would say that we will be answering these questions afterwards for more details if you need them. But yeah, Katie, jump in.
I wouldn't say off the top of my head we have like a specific tangible resource necessarily, unless Sarah, you want to correct me. But within the professional services division at our center, we do host leadership development programs. So in addition to kind of the more curriculum focused professional development, we have historically hosted more sort of strategic planning type events that are meant to convene leaders and classroom educators to think through all of the components that are needed to institute, a successful rollout of HQ instruction, as you said. And so I would encourage you to check out our website, check out our events page. we had a bit of a hiatus for a time with the pandemic and not hosting as many in-person events, but we're planning more in the future. And those, I think, have been incredibly beneficial to school systems and districts that are looking to take a really sort of systemic and structured approach to implementing these kind of strategies. Sarah, did you have something to add?
Yeah, I'll just add, if you did buy Smithsonian Science for the Classroom through Carolina, that a program for implementation comes with that they work through with you. So I did want to mention that.
Perfect. And I will say we are at the 30-minute mark, so I'm going to close this out in a few minutes, but I'm actually going to put this slide on the screen while I go through my last remarks in just a few moments, but there is a QR code on your screen there. And it was actually just going to what you were saying just now, Sarah, so that, the Smithsonian Science K-8 curriculum is now available exclusively through Carolina. So just put that on your phone there with the QR code, and you should get all that information there. And I will just say really quick again, before I go through my closing slides, don't forget to stay on until the very end to participate in our post-event survey. We'd love to hear from you. But first off, before going through my closing slides, just want to thank you to Katie and Sarah for your time here today. And of course, thank you to Carolina Science. And I'd like to take a minute really quick to thank you, our audience, for joining us here today as well. For those of you who enjoyed our presentation, we have more EdTalks like this one that are provided by district administration. Also, if you would like to watch this presentation again, or for those of you who believe that what you heard will be helpful to your colleagues, I'm sure that is very much the case, you will be pleased to know that our team here at DA, we will be sending you an email later tomorrow, and that email, it will include a link to the on-demand recording of this presentation, as well as a link to these slides here. So look out for that. So with that, on behalf of DA, this is Stephen Blackburn. Thanks, everyone. Have a great rest of your day. And of course, again, thank you to Carolina Science. This was great. Thank you.